All right, today we're going to get into lesson 2.4. It's on transformations in the coordinate plane. We're going to be looking at three basic types today. We're going to look at translations, reflections, and rotations. Okay, I think you guys have seen this stuff before, but just want to go through it in detail and look at some of the example type questions you're going to get today when you do your homework assignment on the ALEX. First of all, let's talk about some terms and definitions. Okay, a transformation is defined as a function that takes points in the same plane as inputs and gives other points as outputs. So each of the three styles I talked about, the translation, reflection, rotation, have a different way of taking these points and moving them to other positions. So they take the points as inputs, will apply whatever of the three styles we're given to do, and then that style will determine where the outputs go, and then eventually how we will redraw that shape. Okay, the pre-image is the original figure that they give us. So the original figure that's given that we're being asked to perform this transformation on is called the pre-image. The image is the resulting image that we get after we take and perform the transformation, the reflection, rotation, or translation. And then these are called rigid transformations or asymmetry. Okay, and we call it this because or I'll just read the definition, I guess, called a congruence transformation is one in which the position of the image may differ from the pre-image, but the two figures will remain congruent. It's called rigid because the shape stays exactly the same. It just moves to a different location in the coordinate plane. So that's what we call a rigid transformation. So all of these, reflection, rotation, translations that we do, we will create a new shape, but that new shape is going to be congruent to the original. So the image is going to be congruent to the pre-image. All right, let's look at translation first, which is also called slide. Okay, we're going to take all of the points of the original figure and we're going to move them the same distance and in the same direction. Okay, it's called a translation vector. Okay, and it looks something like this. So if we're going to translate a point along a vector given to us, so notice the look of this parenthesis here is different. All right, that indicates a vector. Essentially, what we're going to do is the A is what we're going to add to the X coordinate of the pre-image. The B is what we will add to the Y coordinate of the pre-image. Okay, so this is vector notation, and this is function notation. This is actually what we do with the vector. Guys, sometimes today they're just going to say, hey, take this point and move it 4 to the right and down 3. Okay, 4 to the right would be 4 for the A, down 3 would be -3 in place of the B, and we would do the same kind of stuff. So a translation is going to look something like this. So we start with our pre-image, which is this triangle ABC. We're going to slide it. It looks like we're going over and down. Each coordinate's moved over and down. And then this new triangle, which we will label as A prime, B prime, C prime, this is our image. This is the one that we've created from the pre-image. And notice that, triangle ABC has become triangle A prime, B prime, C prime. And these two triangles are going to be congruent. Okay, so this first one says, first example here, translate the figure 5 units to the right, and then decide if each statement about the translated figures is true or false. Okay, so first of all, if I'm going to move this image, this pre-image 5 units to the right, the first thing I want to do is I'm going to move it by its vertices. I'm not going to try to move every point along it, just move it by its vertices. So I'm going to start with this top left vertex and I'm going to move it 5 to the right. So I'm going to go 1, 2, 3, 4, 5. Okay, I'm going to take this point and move it 5 to the right. Take this vertex, move it 5 to the right, this vertex 5 to the right, and then I kind of redraw it, and there is my image. So here's the pre-image, here is the image as it's been translated 5 units to the right. Okay, pretty basic stuff. Questions now. If two sides are parallel in the original figure, then the two sides are parallel in the final figure. Well, that's going to be true because these two are the exact same shape. We've replicated the exact same shape. The final angle measures are the same in the original angle measures as the original angle measures. Well, yeah, these angle measures are all going to be the same. It's the same shape. the final side lengths are shorter than the original side lengths. Well, that's false because they're exactly the same, and the original figure and the final figure are congruent. That's true. The shape is going to be exactly the same. Okay, so that's the idea of the slide. Okay, in this question, it says translate the solid figure exactly, can we translate the solid figure exactly onto the dash figure? If not possible, click not possible. So remember, when this is our pre-image in A, and this is our image. So we're trying to move the blue solid onto the dashed one here. Well, remember, this is a slide, so all of these points get moved the same. All right, so if I was to take these points and try to slide them up here, it's not going to match this shape. Okay, because we have to move the vertices here the exact same way every time. So this shape isn't going to turn or anything. We're just going to slide it up here. So this one's not possible. Now over here, if I were to take my original image and slide all the points to the right, and it looks like if I was to slide them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the right, if I was to take each of these vertex and slide them 10 to the right, I would make this exact shape. So yeah, this is definitely a figure that we can recreate through a translation, and we would do it by moving it 10 units to the right. Okay. So now we're going to take this triangle and we're going to translate it 3 units left and 3 units down. Okay. So when I do this, I'm going to, first of all, label the vertices because these are what I'm going to move, and then I'll just connect the dots afterwards. So 3 units left, 3 units down. Okay. So I'm going to take this A point and go 1, 2, 3 units left, 1, 2, 3 down, and that's my A prime. B, 1, 2, 3, 1, 2, 3, there's B prime. Take C, 1, 2, 3, 1, 2, 3, there's C prime, and now connect them. Now you're going to have a tool to use on the Alex program today that's going to do this. Okay, you'll probably have to locate the points and it'll do that for you. But you will work through that program today to do these types of things. Okay, the next, well, actually, this is another one in the slide or in the translation category. In the coordinate plane, the point A is at 0, 2, and is translated to the point A prime at 2, 1. Under the same translation, the points B and C are translated to B prime, C prime. What are the coordinates of B prime and C prime? Okay, so the first thing we need to do is to label our point A and A prime. A is at 0, 2. A prime is at 2, 1. All right, now based on this, okay, what was the translation from A to A prime? Well, it's 2 to the right and 1 down. Okay, so A to A prime is 2 to the right, 1 down, which, as if I put it in this vector form, we're going to go 2 to the right, so that's plus 2 to the x. 1 down, that's minus 1 to the y. So I could write it as a vector like this. All right, the question was, what are the coordinates of B prime, C prime? Well, B was at 3, 0 right here. Okay, I'm going to go to the right 2, down 1. There's B prime. Okay, C is located at 4, 5. 4, 5. So using that same vector, 2 to the right, 1 down, there's C prime, and that location is now at 6, 4. Okay, again, if you look at this, go back to the vector, I add 2 to the x, take 1 away from the y, there's my new point. Add 2 to the x, subtract 1 from the y, there's the new point. But that's how we could use vectors, and that's that style of question. Okay, the next one is a reflection, which is called a flip, and you'll see why in a second. We have to have a line of reflection to determine how we're going to do this flip. Okay, and each point of the pre-image and its image are the same distance from that given line, and that's how we do it. And I'll show you what that means here in a second. Okay, so if you look at this line, so here's the line that we're going to reflect. Here's my pre-image ABC. We're going to reflect it over this line. So what we need to do is count from B to the line and then move that same distance from the line to my B prime. So we're working perpendicular to the line. So A, move perpendicular, right, horizontally to the line, and then move horizontally away the same distance. That's my A prime. C to C prime. Now what this is if you think of taking this ABC and flipping it over the line, it would become this image over here. Okay. And we will reflect over the X and the Y axis, as well as they could give us a vertical line, which would look like X equals some number, or a horizontal line, which will look like Y equals some number. We can flip it over those as well. Okay, let's take a look at a couple of these. It says the point A is shown below. You can see it's located at 3, -4. Reflect A across the Y-axis, then reflect that result across the X-axis, and plot only the final point. So only plot the final point in your answer. That's your directions for tonight. Okay, so let's take a look here. If I'm gonna reflect it over the y-axis first, then A is 3 units away from the y-axis. So count from A to the y-axis in a horizontal line, 1, 2, 3. So now from this line, I want to go 3 units to the other side of it, and there's my A prime. Okay, so that's the first movement. Now we want to reflect this or flip it over the x-axis. So how far from A prime to the x-axis? Well, that's 4 units. Now I want to continue in that same path 4 units to the other side of the line, and there's my A double prime. Okay, that's how we usually do it. There's A prime the first movement, there's A double prime the second movement, and it said only plot your final point. So this would be the only point in your answer right there. Okay. Okay, reflect this figure across the y-axis, then decide if each statement about the reflected figures is true or false. Okay, so if I'm reflecting this over the y-axis, again, I'm only going to reflect the vertice points, and then I'll draw it in. So I'm going to start with this first point up here in the left corner. It's 7 units from the y-axis. All right, so now I want to move 7 units in that same line away from the y-axis, and there's my first point. Okay, go to the next point. It's 5 units from the y-axis, so move 5 units to the other side. There's my second point. Come down here. This vertex is 6 units from the y-axis, so I go 6 units in the other direction. Same line, 6 units. There's that point. And then my final point, 4 units away. Move 4 units away. Okay, reconnect, and there's our image. So it's been flipped over the y-axis. Okay, questions. The final angle measures are smaller than the original angle measures. That answer is false. These two are the exact same figure. The angles are the same, the line lengths are the same, everything's the same. If two sides are parallel in the original figure, then they're parallel in the final. Yeah. The final lengths are the same as the original lengths. Yeah. And the original figure and final figure are congruent. Absolutely. We recreated the same thing. Okay. Draw the reflection over the following triangle over the line M. So now they're giving us a line that's not the X or the Y axis. Okay. This horizontal line is the line Y equals -2. Okay, it's going through the y-axis at -2. We do the reflection the exact same way. Okay, so let's start with this point. This point is 1 unit away from this line. So go 1 unit below it, and there's my new point. There's my new location. Okay, this point is 3 units away from the line. So go 3 units to the other side. That's its location. This point looks like 5 units away from this line. 1, 2, 3, 4, 5. So go 5 units below. That's its new location. Connect them, and there we go. Now we flip this over this line. Okay, you always work to the line, away from the line. Pretty straightforward. Okay, the last one is a rotation or a turn. Okay, so what's going to happen now is you're going to think of it as the shape kind of being the end of the hands of a clock. And the origin is where the center hand is located, and it's just kind of spinning around. All right, so we're going to rotate it or turn it. Each point in the original figure and its image are the same distance from the center. That's what I was talking about. We're going to rotate just 90, 180, or 270, and it can be counterclockwise or it can be clockwise. And guys, this is all about using the rules. If you're going to move it 90 degrees counterclockwise, and that's the same as going 270 clockwise, then your rule is take your ordered pairs, and the new location will be the opposite of Y is now the X position, and the X coordinate is now the Y coordinate. Okay, 180 degrees doesn't matter if you go clockwise or counterclockwise, it's the same. You're going to take your 2 coordinates, you're going to leave them in the same order, but make them both their opposites. And then the 270 counterclockwise, which is the same as 90 clockwise, you follow this rule. So you interchange the X and Y and you make X its opposite. Guys, you got to write these rules down and use them. It's not hard to do. You just have to know them. I don't have them memorized. I use these rules. Okay. This is what it looks like. So here's our origin, right? Here's our pre-image. If I rotate it 90 degrees to the right, I'm just spinning this thing down, and we're spinning everything to the right. Okay. Pre-image, image are exactly the same. Okay, let's take a look at an example here. The figure below has a point marked with a large dot. First, rotate the figure 207 degrees clockwise around the origin, then give the coordinates of the marked point in the original figure and the final. Okay, so here's the drawing. All we got to do is worry about this point. Okay, so this is a 270 degree clockwise rotation. So go to your rules, and here's what it says to do. Take the ordered pair, which our ordered pair is 3, -6, and apply this rule to it. All right, so I'm going to take the x coordinate, and that's going to become my y. I'm going to take the y coordinate, its opposite. So the opposite of -6 is 6, and that's now my x. So my new point is located at 6, 3. 6, 3. Okay, so what's the original point? 3, -6. What's the final? 6, 3. It's all about using those rules. Okay. So we're going to rotate this one 270 degrees counterclockwise around the origin, and then check these statements out to see which ones are true about the original figure, which is called the image, or the pre-image, and the image. Okay, so again, I'm going to write down my rule. 270 degrees counterclockwise, this is the rule. Okay, so take our figure and locate the points. I called them A, B, C, and D, the vertices. Okay, I'm going to list them right here. A is at 1, 4, B is 2, 4, C is 5, 1, D is 1, 1. Okay, now apply the rule to each of these. So the new A prime, interchange X and Y, make X its opposite, is at 4, -1. The new B prime, interchange them, make X its opposite, is 4, -2. C prime, interchange these two, make X its opposite, 1, -5. D prime, interchange, make X its opposite, 1, -1. Now we go over here and plot them. So A is 4, -1. B is 4, -2. C is 1, -5. D is 1, -1. Retrace them. And there is a rotation, guys. We rotated this thing counterclockwise. So we start here. Think about going quadrants. That's 90, 180, 270. Okay, that's a rotation. Notice the shape isn't oriented the exact same way because we've turned it as we went. Okay. Answer the questions. The final angle measures are smaller than the original. False. It's the same image. If two sides are parallel in the figure, then those sides are parallel in the final. True. The final side lengths are the same as the original. True. The original figure and final figure are congruent. True. Okay. Last example. Let's draw this figure 90 degrees counterclockwise around the origin. Okay. So take out your rule. 90 degrees counterclockwise. There's the rule. Okay. Label your points A, B, and C. A is at 2, 5. B is at 5, 4. C is at 3, 1. Apply the rule. A prime is now at -5, 2. B prime is now at -4, 5. C prime is at -1, 3. Okay, that's just taking the points, applying the rule. Plot them now. Here's 5, -2, or -5, 2, excuse me. Here's -4, 5. There's -1, 3. Connect them. 90 degrees counterclockwise, guys, is moving it to the left, right? One area, one rotation here, one quadrant. So there's what it would be if I rotated it. Okay. All right. There's additional examples and explanations if you want to go to your McGraw-Hill textbook. We haven't used it a ton, but there's a bunch of stuff there that you can look at to get more information. Rewatch the video if you need to. Hopefully you've taken your notes. All right. And homework is on Alex, and I'll let you guys get at it.